Hello, you're welcome. So in this video, what we are going to do is to try and see some examples where we are trying to solve, first order differential equations of the, you know, what we talked about last time, trying to go through all those things to derive the solution of the first order differential equation or partial differential equation. We want to see in what examples or in some scenarios where we can apply those, okay? So in my first example, I'm given an example like ux minus 3uy being equal to 0 with this condition here. Oh, my bad. X0 is equal to e to the power x. Okay, so now we know that u of xy is so simple. It's just going to be f of ay. What is a over here? Is just 1. So y minus what is b over here? B is -3. So that's just going to be what? Plus so b x, so that's going to be plus 3x, and that's it. That's just the solution. But with the condition, you have u of x 0. Wherever we see y, we put in 0. We're going to have f of 0 plus 3x, that's f of 3x, and that should be equal to e to the power x. Okay, so we just let this 3x because we just want to have a function of something, a variable, so that we can have the most general solution. Okay, so we let 3x to be, or let 3x be another variable z. Then we can say we have z is equal to 3x, right? Which implies that x is going to be z divided by 3. So in actual sense, I can call f of z to be equal to e to the power, wherever I see x, I replace that with z, and that is what I have over here. And what are we saying? We are saying that the solution u of xy is equal to a function of y plus 3x. So it's a function of y plus 3x. And then we know f of z to be e to the power z on over 3, which means that this is going to be e to the power y plus 3x all divided by 3. And this is the solution to the, or the general, the solution to the first order differential equation above. Another example is going to be a bit tricky, but it should be fine. 2ux plus 5uy is equal to 0 with this condition: ux of 0y is equal to 3y squared. Okay, now we know the solution already. We know the general solution. We know how it's going to look like. We know that u of xy is just going to be equal to function of 5x minus 2y. Okay, yes, but the condition given here isn't u of 0y, it is ux of 0y. So we are then required to differentiate this one with respect to x, or the u of xy with respect to x. So ux is going to be 5, right? 5 times the derivative of f with respect to s, or with respect to x, and this is what we have. Okay, yeah. And then now we know that ux of 0y is going to be, wherever I see s, I'm going to put 0 there. So I'm going to have 5fx of, wherever I see x in the function, I'm going to put 0. So that's going to be negative 2y. And that should be equal to 3y squared. Okay, so this implies that my fx of negative 2y should be equal to 3y to the squared divided by 5, right? Yes. So we can let z be equal to negative 2y, and that implies, or that we are basically saying that y is equal to negative z divided by 2. Okay. All right. So if that's the case, then we have f prime of z being equal to 3 over 5 of minus z on 2 all squared. Why are we saying f prime of z? We've changed the whole coordinates. We've moved from the xy to just simple z. Okay, we are replacing whatever is in the function with just z. So we can just do away with the partial derivatives and then just have a function, a prime of that. Okay, so f prime of z is just equal to that, and then that is going to be equal to 3 over 5 multiplying z squared divided by 4. Okay, so this is going to be 3z squared divided by 20. All right, yeah. So this implies that f of z is going to be equal to, if I try and then integrate this one with respect to z, I'm going to have z cubed divided by 20, right? Because it's going to be 3z cubed divided by 20 times 3, and then the 3 cancels the 3, and that should be plus c. Okay, yes, so that's my f of z, which implies that my f of 5x minus 2y should be equal to 5x minus 2y to the power 3 divided by 20 plus c. And this is the general solution to the partial differential equation above. Okay, yes. So let me add this. So let's pick the case where we are talking of a transport equation. So the transport equation is always going to look like this: ut plus cux equals 0. This is the basic one. Okay, a basic transport equation. And c here is known to be the speed of it, of the whatever material that is being transported from one point to the other. And looking at this, you can easily see that the solution is just going to be a function of x minus ct, right? Think about it and know, let it settle that u of xt is actually going to be f of x minus ct. Okay, yeah. So hope to see you in the next video, and in the next video I'll try to see if we can talk about the wave equation, or we may talk about the conservative laws.